Lesson 7. Access control lists. In this video lesson, guys, I am going to show you what is the main purpose of using access control lists in the network and how to make the basic configuration of it. First of all, we'll take a look, for example, of the ACL, of the access control list in action. So we have an example where students are coming into the university and they have to pass through the security. Whereas the security man have to ask you to show your student ID. And for those people who got student ID, so for example, he got student ID. And here we have the list of rules of the security guy. So he will make permission if the student got the student ID. So he is permitted to enter to the university area, and he is also permitted because he got an ID. He is also permitted due to that fact that here we have these rules. And the last person who doesn't have an ID, he will be denied. So he will go home and relax. So that as we can see here, a small example where the security guy is making filtration of the students. In the same way, in our packet flow in the network, in computer networks, we have an element which is making the same filtration by some given rules. So that if we have an example with you of such kind of example, like we have router 1, which is having the list of rules, like from which network you are, asks router 1 when the packet flow comes through gigabit 00 interface. And here we have two rules: permit packages to pass from network 10.0 with prefix 24 and deny packages which are coming from 20.0 with prefix 24. So that imagine that some of these packages are coming from 10.0 and this packet comes from 20.0, 10.0 network, 20.0 network, and here we have these networks, guys. So that so this packet comes from 10.0, and if here we have the rules that the 10.0 packet will be available to pass, so then it will available to pass, like permitted. Alright, packet comes from network 20.0, denied, permitted, and denied. So the security guy is now here in the router, which is called security, which is called the ACL, access control list. Our students are now packages. So students, packages, security guy is the access control list. Well, we have two types of ACLs. One type of the ACL is called a standard ACL, which can make filtration only by source IP address or by source IP addresses. And so standard type got ACL ID starting from 1 till 99. An extended ACL can make filtration by source and destination IP addresses, by protocols, like it can make filtration by IP protocol, TCP, UDP, ICMP, and so on, and destination port numbers. So as you see, extended ACL got a lot of variants of making filtration of the packet in comparison with the standard ACL. An extended ACL got IDs from 100 till 199, whereas the standard ACL got IDs from 1 till 99. Well, how to make configuration of the standard ACL. And here we have the scenario. In our scenario, we have to permit communication from PC0 and deny communication from any other devices, so that we'll make filtration from. So this is going to be from network. Well, we have in our topology router 1, which is connecting to two networks. So let me write here, network addresses are going to be 192.168.10.0 with prefix 24. And here we have network number, network address like 20.0 with prefix 24. And now our idea is, as you see here in the scenario, PC0 will be available to pass through this security, and PC1, and as you see here, and deny from any other. PC1 and others will be denied. PC1 and others will be denied. So that in case if you will make connection of here of PC2, PC3 and PC4, PC5 and so on, all of them will be denied to make communication like this. Whereas PC0 will be able to communicate with and send the packages through the router 1. And how to make this configuration? First of all, we are creating the access list in the global configuration mode. We type the command access list. Then we are defining the ID of access list, and as you saw it from the description of this slide, standard ACL starts from 1, so it can be used as ID 1 or 99. So that in case if you are selecting here ID from this range of available IDs, like from 1 till 99, then you will make configuration of standard ACL, and your ACL will be able to make filtration only by source IP address or IP addresses. Then we are defining the action. Will we make permission or deny? So we have two variants of writing after ID in standard ACL: permit or deny. So that we are defining permit. So access list number 1, which will make a permission to, so here we have the host. Well, this is optional value, which is defining single IP address. So after you type it host, then you have to type only IP address. You don't have to define the prefix or the subnet mask. So you are saying that permit only for single host 192.168.10 and 4. And then you are writing second rule so that you have single access control list. It's like one security guy which can have multiple rules. So first rule is permit host 192.168.10.4 and deny, and here we have any value to all hosts, to all other hosts from any network, from any IP address from that network, and so on. Well, by the way, guys, in case if you will not type this command, when you are creating an ACL, when you're writing first rule of the ACL, your access list will write this command by itself. So by default, this command will be written at the end of any standard access list, even if you didn't do it. If you permit to any host or network, then you deny to all others by default. So access list is doing this job for you instead of you. Or if you are denying to any host, then it will also deny to all other hosts. Okay, and then after we created an access list, so this process of creating access list is finished, and then we have to assign our access list to one of the two ports. So we have two ports of the router, gigabit 00 and gigabit 01. So that in case if you are selecting gigabit 00 port and if you want to assign your access list into that port, then you will have inbound ACL in this situation, because traffic is coming from this side, and when traffic will enter to the router will make, first thing, it will make filtration by access list. And that is why you're writing here IP access group, and this number is the same number as your access list ID. So it's defining the access ID, access control list ID, and then you are defining in. It means that when traffic comes into this interface, you will make filtration at first, so that inbound ACL, first thing which will be happening when packet comes in, ACL will make filtration, ACL filtration. And second job which will be done by router is routing. It's like, you know, our router got two network addresses and our routing table is looking like this. Okay, so that first step, our packet is coming from PC0, so let's say from PC0 to server 0. And inside our packet we have source IP and destination IP, where source IP is going to be written as 192.168.10.4. Destination IP is going to be 192.168.20.4. So that when this packet comes in to interface, due to that fact that we made up configuration of inbound ACL, our first job will be ACL filtration, and the packet will be filtered, as you know, that it will take a look for the source IP address and it will make comparison. Access list 1 permit host 192.168.10.4. Alright, after this checking, ACL makes up decision that this packet is able to make communication through this port, okay? Because it is successful, it is making a permission for us. And then after ACL found the permission for this host, it is not looking for the rest part of the list, because maybe we have here thousands of rows for in one ACL we may have thousands of different rules. So that after a router finds out the rule which is satisfying the source IP address in this situation, router will go and make the second step. It will take a look for which destination network this packet is going, and this packet goes to network 20, so that router will start to make routing, and it is searching for for the network address. No, it's not this network address, and then second network address, and it is finding out that network 20 is connected through gigabit 01 interface, so that router will make this routing and will resend the information through this gigabit 01 interface. But in case if our PC1 will try to make communication, for example, with server 1, so that in our packet there will be written source IP address, which will be looking like 192.168.10.5, and our destination IP address will be 192.168.20.5, so that when packet comes into the router, first job of the router, it is making the filtration of the ACL, because we made up configuration of inbound ACL, and then it is making filtration. Our source IP address like this, it's looking here host 10 and 4, but our IP address, source IP address is 10 and 5. Then it's not satisfied, this rule, with our source IP address, and it's looking for next rule and saying that deny to any excluding all IP addresses excluding this one, and our IP address in this situation is any, and it means that our packet will be declined, so that router will not make routing for this packet due to that fact that our access list is making filtration. It's like this computer is not able to communicate through gigabit 00 interface. And now it's time to make a small configuration in our packet tracer. First of all, we'll make a test with you guys of communication. Let's check, do we have communication from PC0 to server 0? Here we have successful communication. Do we have ping from PC1 to server 0? This is successful. Do we have ping from PC1 to server 1? Failed due to that fact that we have an ARP process, and successful. Do we have pass from PC0 to server 1? Successful. Every end device can make communication with other device. And now we'll try to implement these rules so that our router 1 will be configured with the standard ACL. We have to go to global configuration mode, and in global configuration mode we are creating access list number 1, and then we are saying permit host 192.168.10.4 and access list 1 deny any. Alright, so that when we are writing deny any, all other hosts will not be able to communicate. And then if we'll take a look for show running configuration file, here we can search for the information of access list at the end of the list. Here it is. This is our access list number 1. Or you can type the command show access list. And it is showing you only information about access list without any other configurations of which are stored in running configuration file. And then we have to implement our access list. As we had an example, we will make with you the inbound ACL configuration. And we have to go to configure interface gigabit 00. And we'll just write command IP access group 1 in. And if you'll take a look for your running configuration file, in running configuration file you can find out that it is configured with IP access group 1 inbound ACL. Now it's time to make a check. Previously we had ping with you from PC0 to these 2 equipments and from PC1 to also 2 equipments. 2 servers. So PC0 is able to communicate with server 0 and is able to communicate with server 1, whereas PC1 is not able to communicate with server 0, so we'll check again. You see, failed. And PC1 is not able to communicate with server 1. Alright, and it's happening due to that fact that we have here a filtration of our access list. In case if we will take off the configuration of the interface gigabit 00 interface, we will say IP no IP access group 1 in, and if we'll try to now make communication from PC0 to server, then it is successful and successful. If we'll take it off, if we'll implement it one more time, we'll see that it is impacting immediately, so it's not able to communicate with both of these servers, because now he is denied IP address. He's using a denied IP address. Well, how to delete access list? You can type the command no access list 1, and then it is deleted. Also, let me delete configurations of my gigabit 00 interface, so that I write no IP access group 1 in, so that now I have full communication from PC1 and PC0 to all other servers. It's time to take a look for the so we have to make configurations. I think that's we have double same slides. Okay, let me skip the second slide. Now it's time to speak about the outbound ACL. Whereas outbound ACL is so we are creating access list as we made up as we created it before, the same command, but then we are making configuration of gigabit 01 interface here, and we are saying IP access group out. So the difference between inbound ACL and outbound ACL, that outbound ACL first job of the router will make routing, and then router will make filtration. For example, our packet from PC0 is going to server 1. We have source IP address of this packet, which is going to be 192.168.10.5, whereas destination IP address is going to be 192.168.20.5. Well, and after this packet is entered to gigabit 00 interface, due to that fact that we don't have any access list on gigabit 00 interface, router will make routing. It will start to search where to resend this packet. Not here. Alright, here, and gigabit 01. And then when router will make this routing and this packet will try to exit through gigabit 01 interface, router will make a second step, because it is configured, you see, in interface gigabit 01, so that then router will make a check. So like IP access list one permit host from host 10.4. We are not 10.4 host, so that is why it's take a look for the next rule, in which rule says that access list 1 deny any. So again, this IP address is not 10.4, that is why it is denied. And then after a routing happened, router 1 made up ACL filtration, and after ACL filtration, router defined that this packet is not able to pass to destination, and it will be denied here. Standard ACL configuration. Here we have another scenario in which we have to permit communication from network 192.168.10 and 0 with prefix 24 and deny for any other networks. So it means that we have here network, so this is our full network, guys, and in our rule we have to permit communication from all this network, I mean from any IP address of this network, and we have to deny for any other IP addresses. How we have to do it? We have to type the command router1 config access list number 1 permit, and then we in previous example we used here optional value host, which is defining the single device, single IP address. But in case if we are not writing host, then we can define with you an IP address, I mean the network address, here it is, and then we can define here the wildcard mask. Where is the wildcard mask, guys? I think that you didn't see the wildcard mask before. Whereas wildcard mask is looking like is equal to 255, 255, 255 and 255 minus subnet mask. So like this, minus subnet mask, and then you will have your wildcard mask. So that in case if your prefix is 24, then your subnet mask is looking like 255, 255, 255 and 0. If you want to find out the wildcard mask of this prefix, or for this subnet mask, then you have to use this formula. It's like 255, 255, 255 and 255, subtracting our subnet mask, where subnet mask is equal to this value. So at the end we'll have with you 0, 0, 0 and 255. So the wildcard mask is actually inverse of the subnet mask, and it is defining the number of useful hosts inside the network. It is defining also at the same time the prefix value. And if we have to permit network, full network here, then we have to just write access list 1 permit. We are defining network address and we are defining the prefix through the wildcard mask. So in case if our prefix will be, for example, 30, what will be equal to our wildcard mask? So the subnet mask of the prefix 30 will be equal to 255, 255 and 252, so that this is our subnet mask, and our wildcard mask will be, so if we'll make the same job, it will be equal to 0, 0, 0 and 3 subnet mask. Oh, sorry, this is going to be wildcard mask. And then by using this command we are defining one network. As in our rule we have to define full network to be to permit the communication. And for other networks or any other IP addresses we are denying the communication. So we are creating editing our access list 1, deny any. And then we are including implementing our access list into gigabit 00 interface. So then it's going to be inbound ACL. So the first job will be what will be happening in the router, ACL filtration. Second job will be what will be happening. It will be routing. And then let's try to make the implementation of this task. So we are writing IP, so access list 1, or let's say access list 20, just an example. And then we are writing permit for network 192.168.10.0 with wildcard mask of prefix 24. And then we are saying access list 20 deny 192.168.10 and deny any. So that and we have to also go to interface gigabit 00 and say that IP access group 20 in. And when we will try to make communication from PC0 to server 0, it is available to communicate. From PC1 to server 1, also available to communicate. And actually, to check this work, we have to change the IP address of one of this equipment. And also we have to change the IP address of the router, for example. Now we are changing our IP address. It's going to be something else, like it's going to be 30 and 4, and our default gateway will be, as an example, 30 and 1. So that we have to also change the IP address of our interface gigabit 00. We'll say that IP address is going to be 192.168.30 and 1 with subnet mask of prefix 24. And now, if this computer will try to make communication with the server, it will be failed, due to that fact that in our access list we are permitting to only 10 and 0 network addresses, and to all other addresses we are denying. So let me change back my IP addresses. And here it is, not 30 but 10, and here we have also not 30 but 10. Well, and also let me go to interface gigabit 00 and say that no IP access group 20 in. By the way, guys, each interface can work only with one inbound ACL and at the same time with one outbound ACL. So if you will try to implement multiple inbound ACLs, for example, to one interface, then the last inbound ACL which you configured will be in use, and the previous one will be just changed with new ACL ID. Order makes sense in ACL, guys, so that if you are typing, so if we have the scenario that PC0, so permit communication from PC0, like he will be available to communicate, he will not be available to communicate, and deny from any other IP address. So in case if you'll type access list 1 and firstly you'll deny to any, and only afterward you'll permit to this host, and if you'll implement it to this interface as out, what will be happening? Your router will take a look for first rule, and the first rule will deny to any. And it's like he is looking for the description of the rules, I mean router of the ACL, and it's looking like, alright, deny to any. Alright, and the packet which is coming from PC0 will be denied, and all other communication will be denied, due to that fact that the order is make sense. And let's try to implement this access list configuration for router 1. But first of all, we'll have to be sure that we have that we are able to communicate from both of these PCs to both of these servers, and yeah, we are able to do it. And then let's create an access list. We'll write in global configuration mode, we'll just write access list 1 and deny any at first, and then access list 1 permit host 192.168.10 and 4, and then we'll go to interface gigabit 0.0 and we'll say that or in our case it is gigabit 0.1 and IP access group 1 out, so that in case if we'll try to make this job, it is failed, and let's try again, it's failed, and PC1 also failed. Why? Because first rule is to deny any, and afterward permission is not working due to that fact that first rule is satisfied for any packages. Now let me just delete my access list from the interface implementation, and then let me delete my access list totally, no access list 1, and that's it. Let me try again to make communication, so that for next our example I have to have full connectivity between these equipments. Yeah, I have them.